Okay, for the Connect 4 game, we're going to actually build this in a new project again, like we did with the snake game. So if you open up your Tynker screen and then log in to another Tynker screen, go over to projects, and then we're going to create a new Python project. We'll do a blank Python project. We can get rid of all of that and name this Connect 4. Make sure that your autosave is on so you don't lose your work. All right, so as always, we need to set up our turtle. We're going to do our turtle module and set up a sprite. I'm going to copy this over. So what it's doing is creating our screen. It's putting a 0 delay on it. We're not delaying this at all because we will at some point. Making a turtle named Sprite with these basic setups that we're going to have for this default sprite, so we can just clone it from this point on, because we're going to have a lot of chips. If you've never seen Connect 4, this is Connect 4. We have to make each of these sprites on the screen. So for us to be able to do that, we need a lot of sprites. So we're going to use this basic one. Anyway, the next thing that we're going to do, put some comments here. Create default sprite. After that, I'm going to create the chip sprite. So this is going to be the green chips that you saw right here. We're going to make those. So we need to clone that sprite that we made. So we're going to say chip equals sprite.clone. We're going to change two things about this. We're going to make its shape a circle, which is super nice and easy that that's an option for us. And we're going to make the color green. The next thing that we have to do is create our Connect 4 board. The Connect 4 board is a 7x7 grid, where each grid location is a possible place that you can play and drop a chip into it. So we're going to draw each grid position within the green chip to start. So first thing that we're going to need to do, I want to put a comment in here. I'm going to say create the board. We need to create a list that's blank to hold our chips that we will be drawing to the screen. We're going to have some variables that are going to be constant. Constant variables, or constants is what you really call them, are always in caps. So we're going to say I'm just going to call them constant values. So we have a chip distance, and there will be 30 for the value. So if you want to put in the comment here, distance between chips. So there'll be 30 pixels between chips. You can copy and paste this too. I'm just typing it in. Origin X will be where we start. We're going to do -90. Origin Y, oops, maybe I should just be copying and pasting. Will be -100. And then we need to lay out our rightmost column. It's going to be the origin of X plus chip distance times 6. So that's one big long line. You can just copy and paste that and add those comments in. So let's see what they're saying about this. So that rightmost column is the position of that one on the far right, and we're going to use it later for when we create our user controls. You'll start placing the grid, and you want the origin X and Y to be at the location where we'll start with the chips. So now to create that 7x7 board, we're going to have to loop through and create that board by making them one column at a time. So the variable I is going to be the row number that we're on, and the variable J will be the column number. So rows go across, columns go down. So we're going to start out here. I'm going to copy that code in, and then we'll talk about it. All right, so I'm going to put a comment. So the loop to create the board. So we're going to go through I is column, J is row. So we go through, we create a column, and then we get the column that we just created, and then we add to the column and draw a chip. And I did not get all of this copied for some reason. Let me mess with there we go. So we'll get that column, and then we add to the column while drawing it. So it's going to go through and add in those chips column by column, row by row, until you get this full board created. So if I check what I did here, and you'll see I made a mistake and did chip distance right here instead of just, I wrote out the whole word, so I had to fix that. But if you play this, you should get this board to draw on the screen. Now we need to talk about the player controls. So in here, I'm going to keep moving down. We need to create a chip at the top so we can let the user move it around to decide where they want to drop their chip. So we're going to copy and paste this code right here. And I'm just going to say player controls and paste that in. What it does is change the chip color to blue, and it sets its starting location wherever you've decided that you're going to put it. So blue will be player 1, red will be player 2. This code is making it go to the center of the board by offsetting that X position by 3 times the chip distance, which is a bunch of math you don't need to know because it's showing you. Placing the chip above the board, though, because where it's going to show up is in the top middle, is by offsetting the chip by 7 times the chip's distance in the Y. So if I run this now, I'm going to get this little blue chip that's going to pop up in the center here. That's that. So it offset it to the center and then up here on the top of the page. Okay, so now we need to be able to move the chip. So we're going to learn to move the chip above the board, and that allows the player to pick where they want to drop their chip. So this is what it's going to look like when we're done. You're going to be able to take the chip with your arrow keys and decide where you want to drop it. So we're going to allow that to be moved. So first thing we're going to do is code moving to the right. I'm going to put that right here. And I'm going to put right here running equals true to make the game start running. But I'm going to then just call this move chip to the right. And I'm going to copy in this. They've named it just R for right. And that allows us to offset the chip and move it one spot over each time we press the arrow key to the right. If it's already above that last column, this code right here, the if x is less than rightmost column, lets us know that it can't move any further to the right anymore. Then we need to also listen for that, because if we're not listening for it to be moved, then we can't actually have it move. So I'm going to go and I'll paste this down. This is that on screen. We're going to listen for that key right to be pressed and then call that function R that we just made that moves it to the right. At this point, the right key should work already. When I click play, if I press the right arrow, it should move to the right. And then it keeps going. When it hits that last one, it's going to bring it back to the left-hand side of the screen. Right here. I'm going to set it right back to the origin. So let's talk about moving to the left. And I'm going to paste these in a specific way. I'm going to do the move left right below the move right. So I'm going to say move chip to the left. Maybe give this a little space. There we go. And if I spell move right, that'd be cool. And I'm going to paste this function right here that does that same thing where it moves it across, but this time it's using the arrow key to move it to the left. I suppose it wouldn't even be necessary. You could just move it one way and drop it when you want to, but whatever is clever, we will take what it gives us. Then we also need to listen for that right or the left arrow key to be pressed down to call this move left. So I'm going to put that right here underneath the move right. And this should have it working, so you can now move the blue chip at the top to the left and to the right. And regardless of if you go over, it'll go back again, but we haven't coded anything more than that at this point. So we're going to make a super long function now that handles the dropping of the chip and then stacking those chips on top of each other. And it's going to alternate between red and blue for the player, depending which player is, whose turn it is. So I'm going to go just above this move chip to the right. I could also go below where I was right now. It really doesn't matter. But I'm going to go down here and do that. And I'm going to call this the drop chip function. And it starts out with turn 1. So this is a really long function. So we're going to break it down into a couple pieces here. We're going to start out here by creating a variable called turn so we know whose turn it is. It's going to start with player 1, it being their turn first. And then we need to know whose turn it is, and we want to be able to change that. We also want to be able to change if the game is still playing or not. So we need to use the running and the turn variable. We always need to use that keyword global when we do that. So if we're running, we're going to get the column number where the chip dropped. So we're going to get that and put it into a variable called x. Then, and it does a lot of math to do that. So what it does, we're not even going to go through how it does it. It figures out where you are. It does the math for us. That's all we need to know. So if we need to do this for some extra stuff, we'll talk about the huge math that goes into this, but we're not going to do that for right now. It also then is going to get the column and get where on the board that X is and put it into that variable column. So now that we know which column we're supposed to drop the chip in, we need to add some logic to place the chip in the right horizontal location, not just vertical location. So we want it to fall to the first empty slot. So we need to know if there's a chip already in that slot. And what this code does is just that. So let's go through what's in here, and I've put some extra comments in here for you. So we'll get that column where it dropped. Now we need to figure out where it's going in here. So we're gonna loop over the column list to find an empty slot within that column. And if that slot is empty, the value will be 0. We're gonna change that value to 1 or 2 if that slot gets taken by the next player. So it's gonna go through each one of the rows all the way down in that column, and it's going to decide if that is empty. When it's empty, it's going to stamp that chip, so a red or a blue, and then it's going to set that current grid position, so that XY, equal to the 1 or 2 so you know which player it was. And then it's going to check to see whose turn it is next and change the chip at the top to the color that goes with it. Now you can't forget, we haven't mapped the D. D is for drop. This won't occur until they press the D key, so we're going to listen for that. So we need a screen.onKey. The key is D, and we'll call D. The key is going to be, I'm going to use the D key actually to do it. You could also use the down key if you wanted to. I suppose we could use the down arrow. Down would work as well. The D letter key would work as well. So let's test this. We're going to click play. It's going to draw our chips, and now I can use the arrow key to move. And if I press the down arrow, it'll put that spot in there. And you'll notice if I keep going down the same one, it changes color each time. That's what the code that we just put in told it to do. It said, look at whose turn it is. Change the chip at the top to it. Look to see what the next open one is and plop her down in there. We want to find the empty slot, which is the 0. When it's equal to 0, then we'll keep moving from there and switch turns. Now, the next thing we need to do is detect who the winner is. So each player can move, chips fall in the correct position, but we need to know how to end this game. So we're going to modify the drop function to check for a winner. So to do that, we're going to paste this in. Right here. And then we need to create a function that checks for the winner. So I'm going to paste the code in there. What it's going to check to see is we need to get rid of this too, by the way. We need to get this chunk out of here, because this is doing that work for us now. So it's going to do what it was, where it was changing that turn but checking for a winner at the same time. So if we have a winner, it's going to call the hasWinner function, and that's how it's going to check to see if we have a winner. So let's go put the code in for that. I'm just going to write it right below it. And this will be check for winner. So it has to, this function actually calls 2 more functions. They could have done this all in there easily to make it a little easier to read, but we'll go with what they have. It's going to check the X and the Y location each time you drop a chip to see if a full column or a full row has been filled in. So it's going to check the row first. So let's copy and paste this in, and then we'll talk about the what it's actually doing in each of these. So this is the check row for winner, and then we'll also put in the check column for winner, because you can connect 4 by having 4 in a row several different ways. Now there's no diagonal winning in this one, so that I think will be an option for one of our additions onto it, but I don't know that we're going to do that. So let's look at what it does here. It goes through every row and checks to see if there is 4 1s or 4 2s in a row all the way through each of the rows. And then it does the same thing for the columns, checking to see if there's 4 1s or 4 2s together in a row. And then if that is the case, then it would call the function that tells us there's a winner on here. So let's see if this works, paste it in the way it is. I'm just gonna drop, oh, that should not have happened. We have an error. I have a feeling something is indented in the wrong place. Let's take a peek. I found my error. I accidentally deleted this break statement that has to be there, and that's why I kept plopping them in. So make sure you don't miss that break statement right here at the very end. It's the end of the has winner loop, and I missed mine. So now I can go through and play my game, and let's just get 4 in a row. Oops, that was not helpful. There we go. Player 1 is the winner. So now we have a working game. That was a lot of code.